Hello. Thank you for joining us. In this talk, we will introduce SK hynix's new Memory Forest initiative, aimed at creating ESG values in the data era. Rapid advances in information technology are giving rise to new applications, such as cloud computing, AI, IoT, 5G, AR, and VR. Data volume is thus growing exponentially, now ranging in the zettabytes. That's 10 to the power of 21 bytes, or a trillion gigabytes. According to estimates, global data creation is expected to grow from 33 zettabytes in 2018 to 175 zettabytes by 2025. By the same time frame, 6 billion users, or 75% of the world's population, are expected to come online, while 75 billion devices connect to the Internet of Things. Meanwhile, the proliferation of cloud services is driving explosive growth in data volumes at the data center end, causing a spike in power consumption and total cost of ownership for cloud service providers. As shown on the left, data centers alone are expected to account for 15% of the world's energy use by 2025, while the amount of power needed to run and cool a server rack continues to grow steeply. This also has adverse environmental implications, for which all major cloud providers are making a concerted effort to reduce their carbon emissions and convert to green energy sources. As mentioned, growing power consumption at data centers is not only driving up TCO, but also a direct threat to the environment. Meanwhile, memory is expected to account for a substantial 20% of server power use in 2022 and 35% by year 25. This calls for high-performance but low-power memory systems that process data more efficiently, as the very key to reducing data center TCO and preserving the environment, now more than ever. SK hynix's Memory Forest initiative is our response to such challenges, our vision to ensure sustainable value creation through memory. Just as a natural forest is a holistic ecosystem inhabited by a variety of fauna and flora, Memory Forest is a model that aspires to a similarly rich and green ecosystem of IT players. The name can also be read as Memory for EST, with E for Environment, S for Society, and T for Tomorrow, representing our commitment to creating ESG values in the ever-expanding data world with our global ecosystem partners. A natural forest, shown on the left, consists of tiers starting from the emergent layer and downwards through the canopy, understory, and forest floor. This can be mapped to the hierarchy of memory systems on the right, from in-package memory and main memory through storage class memory and storage at the foundation. From an application perspective, the layers would represent AI and machine learning at the top, supported by real-time analytics, batch analytics, and data lake below. Let us further walk through Memory Forest's broader mission. You would recall that the capital E is for environment. For our industry, key environmental concerns include resource use, cost of ownership, as well as waste, water, and toxic chemicals. Given such, we aim to deliver value for the environment by providing less power-consuming but greater performance and quality products to users, while recycling more, saving materials and utilities, and reducing waste on the production side. Then about S, or Society, in Memory Forest. To create values that contribute to society, cultivating mutually beneficial, growth-sharing relations with our investors, partners, customers, suppliers, and employees would be of utmost importance. We seek to generate social value to all stakeholders by nurturing new biz opportunities for investors, open innovation for our partners, novel solutions for customers, close collaboration with suppliers, as well as safe and ideal work environments for workers. Finally, the T for Tomorrow represents our mission to build memory for the future, with diverse considerations, including the environment, societies, new business models, and future technologies. In line with such, we seek to continue exploring new and better models of business, as well as novel memory solutions that are environment-friendly and socially impactful. There are two possible directions to delivering the memory we envision. One would be to seek continued performance and power improvements with existing memory for greater value and sustainability. The other would involve creating entirely new solutions along the memory hierarchy, such as processing in memory, CXL memory, and near data or in storage processing. We plan to pursue both in order to provide a new portfolio of memory that reflects our mission for E, S, and T. Now let us explore the actual memory solutions that will build up memory forest. The first category would be memory that provides high performance per watt, namely DDR5, HBM2E and 3, and CXL memory. The second would be local compute-based power-saving solutions, such as near data processing, processing in memory, and in storage processing. In this schematic, HBM is shown adjacent to the CPU as an in-package memory, while CXL memory, which utilizes DRAM or storage class memory, connects via the CXL switch. The CXL fabric further enables access to pools of memory outside the system, providing gains in memory resource flexibility and efficiency. Optionally, near data processing units can be configured inside the CXL memory, while in-memory processing can be added in HBM and DDR. Likewise, storage can add optional in-storage processing units. With an expanding portfolio of such new memory solutions, we expect to help reduce data center TCO and realize the values of memory forest. So, how much actual value can our solutions create for the environment, society, and tomorrow? Take DDR5 and HBM3, SK hynix DDR5 DRAM, the world's first launched in October last year, doubles the bandwidth over DDR4, effectively allowing the same or greater system performance to be achieved with a smaller amount of servers. Our HBM3, released in October 2021 with world-leading bandwidth of 819.2 gigabytes per second, can process the same workload as a DDR4 DIMM with 20% less picojoules of energy per bit. Then about CXL memory, which is drawing high expectations as a potential game-changer in the data center landscape. CXL memory will offer scalability of capacity and bandwidth, as well as an added persistency feature in a dedicated type. Tiering or pooling memory with CXL in server systems can allow overall memory resources to be used flexibly and efficiently at less power. Furthermore, using CXL memory can save valuable wafer resources, as fewer wafers are required to build the same capacity modules, thanks to the higher bits per wafer possible for high-capacity CXL memory, and device yield improvement with the use of controllers. Finally, for NDP and ISP, or near data processing and in-storage processing. These computational memory and storage solutions substantially reduce the volume of data transfers, while leveraging the high internal bandwidth to boost system performance and reduce power consumption. As shown on the right, an NDP-only server is expected to save 80% of the power required to compute a deep learning recommendation model compared to a GPU-exclusive system. On top of maximizing the technical value of the solutions described, we seek open innovation with our customers and ecosystem partners to realize the values of memory forest for a better future for all. Ultimately, through our endeavor in collaboration with customers and partners, we wish to help establish eco-friendly data centers for the environment, society, and tomorrow. Rather than fixating on semiconductors, which may well be a single tree within a vast forest, we choose to imagine the larger forest that this tree may create, and harness that ecosystem as a resource for the sustainability of mankind. Embarking on the Memory Forest initiative thus, we are confident and driven in our efforts to create a better future for all. Thank you.